Okay, so the first question says, draw the displayed formula. So when we're drawing the displayed formula, we need to make sure we include all of the carbon and hydrogen bonds. Okay, so mine isn't 100% correct because we would need to make sure that we include like that. Okay, so that is the displayed formula. Okay, but you would have got away with that because of the EZ isomerism. Okay, draw the skeletal formula. So first thing you want to do, hex 6, ene, double bond on the first carbon. So you've got that there. Then you've got a chlorine on the 1, 2, 3rd carbon. Okay, count them along, 4, 5, 6. State the molecular formula, straight chain saturated. So saturated means there's no double bonds. Halogen alkanes whose molecules contain carbon 50 and 100 chlorines. Okay, so halogen alkane. So if you think about an alkane, the general form is CnH2n plus 2. Okay, so you would do C50, H2n, which would be 100, and then plus the 2 Cls. Okay, because there's 2 chlorine atoms. That's where they would be replaced. Next question then says, draw the curve to show the distribution of energies of the particles at the same temperature at higher temperatures. Okay, so you move the curve slightly along, so more particles have activation energy. More particles have activation energy. Okay, activation energy higher with T, curve at a higher temperature. Draw the structural formula used to make this polymer. So that is 2, okay? You can see that that is 2 monomers in one. Okay, so you pick one out and add a double bond, okay, and it would look like that. Really easy question, don't fall down on that. So to test for the presence of iodine, an organic compound is first heated with NaOH. Okay, the following is then added, so nitric acid. So you've got to make sure you add the nitric acid first and then the silver nitrate. And then thinking about your colours, so it would be chlorine is white, bromine is cream, and iodine is yellow. Okay, complete the equation to show the missing products. So this is a carboxylic acid plus an alcohol will make an ester, and then you don't have to draw it like that because it doesn't say skeletal formula. You could have drawn it as a displayed formula. All that happens is the O from here, the OH and the H from this, but you can't really see it, come off, and then that's where that oxygen comes from there. Okay, name the catalyst, concentrated sulfuric acid. Ethanol is a liquid at room temperature. Write the equation that corresponds to the standard enthalpy change of formation. So you look at this and first off work out what elements you've got. So you've got carbon, you've got hydrogen, and you've got oxygen. Okay, thinking about that 7 on the periodic table, oxygen exists as a pair, hydrogen exists as a pair, carbon exists on its own. Okay, and then if you, they're the 3 that form it, that's the end molecule, and then you can add numbers in front to balance it out. And then what you need to do is balance it. Okay, why is it difficult to directly measure the standard enthalpy change of formation? CH and O don't easily react together under just normal conditions. You have to add like different catalysts and stuff for it to happen. Okay, this was a little bit of an odd question then, in that they were just asking you to explain how you would get the answer, the kJ mole answer, okay? They weren't asking you to do any calculations, they were asking you how you would get there. So the first thing you would do is MCAT, okay? Using the temperature change, specific heat capacity, and the mass, okay? Remember, you would just use the mass of the water. Then you could work out the moles of ethanol, okay? Because you've got the mass, because you can work that out by measuring the spirit burner before and after, and then you would divide whatever you worked out, so it's Q over N, okay? That was a really strange question, but actually an easy question. There was no math. It was just using your prior knowledge. It was just... then it says, why is it difficult for the apparatus to turn the empirical change combustion of ethane? Ethane is a gas at room temperature. Practical problems based on ethane, okay? You can't, it's not a liquid, you can't do exactly what they've done in that experiment. Explain the effects of each student error had on the values they obtained in the experiment. Ewan's error was likely to do with a temperature rise or a loss in mass being very small. Karras's error was to do with the mass of the fuel after boiling did not result in a temperature rise. Okay, so you can read that bit of information and extract what you think was wrong. And then moving on, they did then ask you to do a Hess's law, okay? Now, this relied on you getting the equation right from the first bit. Now, there would have been an error carried forward if you didn't get the equation right, okay? So you were expected to use the equation that you used, okay? So whatever equation you had, okay? And then that would have been able to then complete Hess's law, okay? Combustion, okay, remember the arrows go down, okay, thinking about forming Hess's law. And then elements in their standard states, such as oxygen, is just 0, okay? Amir said that hydrogen, and remember to change any arrows, so you can see I've changed the arrow there, change any arrows to make sure it's all root 1 equals root 2. Amir said hydrogen is the best fuel of these three in terms of energy release. Calculate the equal masses, okay? So looking, you had 2 carbons, okay, so did the mass number of carbon, hydrogen, and then ethanol, okay, looking at the answers that they've given you, Amir is correct. Then it asked you to do empirical formula, which is really nice and easy. It said that a hydrocarbon, so something that contains only hydrogen and carbon, had 85% mass of carbon, so that allowed you to work out hydrogen. Empirical formula then gave you a little bit of a dodgy number, okay? Well, it gave you 17, okay? No, that isn't, that's that. So that would have been 7.13, and that would have been 14.26. You can straight away see if you divide by the smallest, you're going to get 1 and 2, okay? It said then the MR was between 50 and 60. If you do 60 divided by 12, okay, it comes out exact at 5, okay, which isn't helpful to us, okay, because you're not going to just have 5 carbons in a row, okay? So then I realised it had to be 4 carbons, okay, because you couldn't just have 5 carbons in a row. So if I did 4 carbons, I've got 12 times by 4, which gave me 48 and allowed me to work out then how many hydrogens I'd have to get the MR between 50 and 60. Okay. Explain what can be deduced from 1.2 grams reacting exactly with 32 grams. Okay. So 0.2 moles equals 0.2 moles, so there must be a double bond. Okay. What type of reaction? So in the absence of light is electrophilic substitution. In the presence of light, thinking about UV light, okay, is free radical or radical substitution. Draw then the displayed formulas for each, okay. So this is what we believe compound X to be. So 1, 2, 3, 4 carbons with a double bond, okay. Then in the absence of light, this is what it looks like, okay. And then in the presence of light, you just had to do empirical formula. Not empirical formula, free radical substitution, sorry. Now, these questions are going to come up. There is going to be a question on the exam for a couple of marks on this. Now, how they do it, it can be anywhere between 6 and 10 marks, okay? So if it's 10 marks, we want to make sure that we use that to the best of our ability, okay? So I've worked it out as though I was working along. So the first thing I did was look at the infrared spectrometry. Notice there was a big peak there and a big peak there. And I've worked them out using our table. And I've just written them there, okay? Then mass spec, remember this, the biggest one at the end is the MR, okay? Now, because there's 3 so close together, the MR could be one of 3 things, okay? That is to do with the fact that there must be a chlorine atom present, and it's either got the mass number 35 or 37, depending on the isotope, okay? Carbon groups then, there are 2. You get a mark for just saying there's 2 different carbon environments, okay? 1 mark for saying 2 different hydrogen environments, okay? Look up their numbers, okay? And then work out kind of what they are. Saying hydrogens in each environment, because they're exactly the same number of hydrogens, okay? So it's got to be 1 for dichlorobutane rather than 2, 3, just thinking about the structure of it. And then we don't need that because that's just on the previous page. Really easy question. Draw the apparatus needed to calculate the volume of oxygen produced. And then you had to do 2 different gradient questions on the next page. Just thinking about gradients, guys. Okay, the first one was looking as close to 0 as you could possibly get. So I picked it there, did my tangent line and got it there. And then this is for the second one. So pause this page and have a look. Okay, so this gradient was the initial rate. So take it as close to 0 as you can. Okay, take it as close to 0 as you can. Go back to the previous page and pause. And then with this, we're using numeracy from last year. We're doing the difference in your y over the difference in your x. Okay, so these are values that I've collected from the tangent lines. Okay, so make sure you go back a little bit in the video just to see where the tangents are. This one then is at 200 seconds. Okay, so it's close to 0. You'll notice my tangent line isn't completely close to 0. Okay, nice 3 marks there. Okay, use conclusion theory to explain why the rates calculated are different. At time 20, concentration is lower. It's been going on a while, so particles further apart, less frequent collisions, less chance of collisions. Okay, then this is from Mr. Mulroy's side. Okay, working out the concentration when you've been given this value. Where you use the pressure and the significant volume to make sure that you get the answer. Okay. That is on Mr. Mulroy's side. Describe how the student can determine if cobalt chlorate is a better catalyst than magnesium oxide. Use the same amount. Okay, a better word to use there would be mass. Use the same mass of catalyst and the same volume of concentration. Repeat the experiment. And see which has a faster rate. Okay. Blank page. Right, last question then. Marks like this. Can you see how this is worth 4 marks here? Okay, 4 marks. We are not losing 4 marks. So you've got your cyanide ion with your negative and your electrons and your negative charge. Goes up to the carbon. That causes the carbon then to give all of its electrons. Remember, there would be 2 electrons shared in this bond, okay, because it's a covalent bond, 2 electrons shared. Both of them electrons then get transferred to the chlorine. Electrons are negative, so that's why the chlorine becomes negative, okay? It induces a dipole. Okay? The cyanide then is added on, which increases the carbon chain. And then you have a free chlorine then to go and do something else. Type of reaction, nucleophilic, because it's something that loves the nucleus, the positive aspect of that carbon. Substitution, because you're substituting the cyanide ion for the chlorine. Okay. 2-chlorobutane is heated with sodium hydroxide, dissolved in ethanol. 3 different organic products are formed. Okay. So these are EZ isomers of each other. Okay. EZ isomers, and then this one is just a normal bond without an isomer. Okay, draw the displayed formula of each. Okay, so when you heat 2-chlorobutane with sodium hydroxide dissolved in ethanol, remember there's different ones. If it's not dissolved in ethanol, that is when you go back from a halogen alkane to an alkene. Okay, type of reaction taking place, elimination, because you are eliminating the chlorine and replacing it with a double bond. Questions like this come up quite a lot. Explain why HFCs are preferred to CFCs. Okay, you do not need to include a mechanism. If they ask you to include a mechanism, you're looking at the free radical substitution mechanisms with initiation, propagation and termination. Okay, CFCs destroy the ozone layer. Exposed to UV radiation, greater risk of skin cancer. Okay, because of the UV radiation, the carbon-chlorine bond in this forms the free radicals that we know about, so then they can attack the ozone layer. Okay, in hydrogen fluorochlorines, it contains carbon to hydrogen bonds and carbon to fluorine bonds, which are too strong to be broken. It's only this bond that can be broken, and if there's CBr, that gets broken before it gets to the ozone layer, so that's no problem either. Okay. Last question then. Suggest that a student can modify these instructions in order to obtain a good yield of pure ethanol. Need yeast to be added to the mixture, body temperature of 25 to 40, and must have a way of letting the CO2 escape. So there's 3 big things. Atom economy then, again, something you will have done with Mr. Mulroy. Looking at the mass of both of them. So the mass of what you want divided by the mass at the start, because if you look at the equation they've given you, it's only glucose to start. Okay, so the equation for that is mass of desired product, just in case you couldn't remember, over the mass of total reactants. Okay, now sometimes they'll actually give you mass, sometimes they'll just ask you to work out MRs. Okay, so you can use their mass numbers as well. Okay, so just be careful of that. Nice question for 2 marks though. Describe one environmental consideration when choosing fermentation or hydration. Hydration needs really high temperatures and pressures and stuff, and it also uses a fossil fuel, so releases CO2. Okay, even though this releases CO2, but we consider this to be carbon neutral because glucose comes from a plant, photosynthesis, so the amount of carbon dioxide that it takes in is equal to the amount that it releases. Okay, whereas if we're using a fossil fuel, which is where ethene comes from, because ethene is a fossil fuel from crude oil. Okay, and it goes through that entire process of fractional distillation, stuff like that. Ethene then comes from cracking something from a crude oil. Okay, so this is a bigger process that requires more energy and releases more CO2. So there's another reason you could have picked fermentation. Okay, fermentation is slower. It's a batch process. You have to remove the product over and over again. Explain what's meant by primary alcohols. Primary alcohols are when the OH is attached to the first carbon, no more than one other carbon attached. Okay, so to do with being a primary alcohol, okay, it's on there with one other carbon attached to it. That's a primary alcohol. Whereas if you do that, okay, that's a secondary alcohol because this carbon has got 1, 2 attached to it. Okay, if I was to add another carbon here, we would consider this a tertiary because it's got 1, 2, 3 attached to it now. Okay, give the structural formula, name of a tertiary alcohol that contains 5 carbons. Okay, so very similar to what I've done here. 1, 2, it has to be 4 because you have to have a carbon with 3 carbons attached to it. Okay, 2-methyl, 2-butanol. One test that would investigate whether the alcohol is secondary or tertiary. Add acidified, it has to be acidified, potassium dichromate. Secondary alcohol will go orange to green. Tertiary alcohol will have no change.